Okay, welcome to card number 6, and we're going to be talking about rheostats and potentiometers. In case you haven't watched it yet, there is another video that I did on rheostats and potentiometers that, actually there's 3 of them, I think. 3 rheostat and potentiometer videos. So, watch them first, and then you'll be able to probably have a little better insight. Now, what I'm going to do here is I'm going to do a review, quick educational component here with some drawings and some, stuff, and then we'll get into the soldering. But the other videos work. This is going to be a lot of repetition because, quite frankly, that's how you learn, by being repetitive. And I'll clean up my mess here, and then we will start on actually learning stuff. So you guys hang with me, and I'll be right back. I want to show you something here, because one of the things I preach in class repeatedly is you're smarter than the majority of people who are building this stuff and designing it. It's just that our intelligence is a different type. We have a tactile, hands-on sort of intelligence that requires us to touch things and look at things and then make decisions. Unfortunately, the people who typically make the decisions are the ones who don't ever look at these. And they, I'll make all the jokes I can about engineers, and the funny thing is that engineers, today are the guys who sat in the front of English class when we were there, if we even went. And they're the ones who made the straight A's, and they get this stuff wrong. Okay, this is wrong. Let me explain to you why it's wrong, okay? First of all, a rheostat technically only has 2 terminals, okay? But you'll notice that this 25 ohm rheostat has 3. So technically, it's a potentiometer. Now, I can wire it as a rheostat by jumping these 2, pins 1 and 2, or pins 2 and 3. I can turn it into a rheostat. But technically, it's a potentiometer. Now, this is a potentiometer, and this is also a potentiometer. So these are correct, but the rheostat technically is not. So what you have to do, I'll start with the 5K because that's the one on the card. The thing you have to do is you have to understand that you're just as smart as or smarter than the guys who do this. All right, so look, 1, 2, 3, 1, 2, 3. All right, that's bad because the same thing happens on schematics. They'll call a rheostat a potentiometer. They'll call a potentiometer a variable resistor, which it is not, because the only one that really is a variable resistor is the rheostat, because it's varying the resistance, which controls amperage, while the potentiometer literally measures voltage. Okay, so you have to be smarter than the guys who do this, and that's really not very hard to do, to be honest with you, because I've met them, and they can do math equations, but they can't quite think themselves out of a corner. So at any rate, the rheostat has 2 terminals, and if you've watched the other videos, this is going to be repetition to you. If this is the first time you've seen it, the rheostat has 2 terminals. That's what's critical. Okay, this is a rheostat because it has 2 terminals. All right, potentiometer has 3. Okay, so this is very important, and you have to understand that these guys, even though there are standards for schematic reading and schematic drawing, they don't use them. So this symbol could also be this symbol, because that's a resistor and that's a resistor. So that's 2 wires, that's 2 wires. Well, here we have the same thing, but what we'll have is this, and we'll have this, this, and this. Okay? Had to stop for a minute there because the dog was barking. That's what you get for working at home, I guess. I really don't like it that much. I'd rather be working somewhere else. But at any rate, okay. So 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, and then we can take the same thing here, and sometimes what you'll see is this, and it just depends upon the manufacturer. But the key is to understand that there are a certain number of terminals. All right, so here's 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, and 1, 2, 3. It's very important to understand that in a potentiometer, terminal 2, unless they're doing something funky, and I've seen one once, but I swear I thought it was misdrawn. Terminal 2 is always the signal wire, okay? If you hook these up backwards, bad things happen, because what we do is we put positive voltage on one side and we put negative voltage or ground on the other side, and this just turns on like a light bulb. I mean, it's the exact same thing as a light bulb. It's just built differently, but you wire it the same way. This, on the other hand, has very, very low resistance on this side if you slide it this way, but if you slide it this way, it has very big resistance. And if you remember, what we have is we have Ohm's law, which says volts and ohms make amps. Now, if you're in school, this is the equation you should use, and you should insist upon it. And if your teacher's going to balk at it, or if your teacher gets a little torqued off at you, you can always write it as volts over ohms equals amps, and then say, well, I'm just going to use these, and then come back and put it back in those terms. I mean, because that's really kind of silly. I think this right here, this is just stupid. And if you've watched that video, you understand why I think it's stupid. It's just stupid. We shouldn't be using that. This is what's on the meter. You never see those again. Okay, so if I slide the wiper this way, the resistor gets longer. Bigger resistance, less current. If I slide the wiper this way, then I got less resistance, more current. Light bright, light dim. Motor slow. Oh, no. Yeah, motor fast. See, that's how easy it is to get resistance backwards. Okay? I mean, I think I'm pretty good at this stuff, and I still screw it up. Okay, so don't don't worry. So at any rate, bigger resistance, less light, slow motor. Lower resistance, more light, faster motor. Okay, but 1 2 1 2 1 2. That's critical. 1 2 1 2 1 2 3 1 2 3 1 2 3. Okay, so that's important. Why is it important? Because language, for those of you who didn't pay much attention in English class, don't worry, because you're smart enough to get this, but teachers just didn't know how to teach to us. RHEO means flow, and stat means not changing, okay? So static, right? Static electricity, not changing. Potentio is another word for voltage, and meter means to measure, all right? So those, I like this example for a lot of reasons. It talks about voltage drop. It talks about Ohm's law. It talks about language and understanding the difference between volts and amps, because they're different. And if you can understand how these work, to be honest with you, if you can understand how these work, then you're going to be in much better shape about everything, because everything that we need to know is kind of in here pretty thoroughly. So that's something to consider. All right. So here's the fundamental difference in terms of the operation. Now, they both work on the same principle, and the principle is volts and ohms make amps, and volts over ohms equals amps. I mean, Ohm's law is everything, right? Kirchhoff's law is voltage drops, and those are all there. So those of you who are figuring this out and go, wait a minute, but don't these both work in the same way? And the answer is yes, they do. The rheostat and the potentiometer both are based upon that law, all right? So whether we're looking at a voltage or changing a resistance, the end result is things are changing. Okay, so the key though to understand is that that this just works on Ohm's law. So let's say that let's just make this up. All right, so I always have to write this down no matter what. Volts over ohms equals amps. All right, so let's say we have 12 volts. All right, and we have no rheostat, and the fan's on high speed. And let's say the fan runs on 2 ohms under normal speed. So we got 12 volts over 2 ohms. Well, the motor's going to be running on 6 amps. That's just the way it works, okay? That's just how it works. But let's say we put a rheostat in, and now we still got the same 12 volts, okay? But let's say we double the resistance by adding 2 ohms of rheostat. So we have 2 ohms of rheostat. All right, well, that makes us go to 4 ohms. So now we're at 4 ohms, right? Well, now it drops to 3 amps. So the motor's going to run what? Faster or slower? Slower, right? Because there's less current flow. But it's also because there's more loss in voltage, all right? So if I were to work this out 2 different ways, it would look like this. Now, I'm doing this on the fly, so if I screw up, I'm going to have to start over again. But if I draw it this way, and I put my battery here, right? And there's my 12 volts, and here's my motor. My motor, we're going to say, has, what did I say, 2 ohms, okay? Then this motor, 12 over 2 is 6 amps, okay? Well, if I do the math, it's going to be very simple, because if I want to calculate the voltage drop is 12, because the motor is the only thing there, right? So I can calculate the voltage drop by saying volts equals my amps times my ohms, because I'm just taking volts over ohms equals amps. This is on the bottom, so when I move it over, it goes up, and that's division becomes multiplication. So volts equals amps times ohms. That's called transposition. We're changing the position of the variables. So my voltage drop, which I don't know at this point, I do know it's 12, but I don't know it, right, is going to be my amperage, which is 6 amps, times my 2 ohms, which means 6 times 2 equals 12. So I've got 12 amps. 12 volts. See? That's how easy this is to screw up. You just got to not worry about it. All right, but then let's say I do this, and I put in the rheostat, right? There's my rheostat, and here's my motor. Okay, so the motor stays at 2 ohms, and this I'm playing around a little bit here, but it's pretty accurate. And then my rheostat, which I'll draw like this because I can. Let's say it has 2 ohms. Well, I got 2 things going on here. First thing I have is I have 4 ohms total because it's in series. 2 plus 2 is 4. I got 12 volts, so I've got 12 volts divided by 4 ohms equals 3 amps. Okay. So I got less amperage, I got more resistance, I got a slower motor. That's how it works, okay? And if you guys old farts like me had slot cars, this is how you controlled your slot cars. Now, here's the thing. I want to know my voltage drop. Well, if it's 3 amps through the whole thing, then it's 3 amps here and it's 3 amps here because it's 3 amps through one wire. All right, well, voltage drop equals amps times ohms. Voltage drop equals amps times ohms. All right, so my voltage drop is 3 amps times 2 ohms. My voltage drop is 6 volts. Amps times ohms, 3 amps times 2 ohms equals 6 volts. 6 volts plus 6 volts equals 12 volts. All right, now what have I taught here? I've taught voltage drop. Okay, I've taught Ohm's law. I've taught how resistance affects current. Okay, and we've shown that voltage drops, if I said this already, voltage drops add up to source voltage. And we've seen that the reason the motor's turning slowly is really because it doesn't have enough voltage. All right, so if we look at this and go, well, wait a minute, the motor does not have enough voltage to work. It's only trying to work on 6 volts. Well, of course it's going to run slow. Well, now we're into the starter voltage drop testing. This is the starter voltage drop circuit problem, the exact same problem, okay? I mean, word for word, letter for letter, number for number. It's the exact same problem. So the motor is going to turn slowly, obviously, because it just doesn't have enough horsepower. All right? Well, but we're changing current flow. Yes, we're changing current flow because that's what it's called. It's called a rheostat. So we're changing the current flow by increasing resistance. But you can look at this 2 ways. Okay, A, you can look at it this way. Low amps. Yeah. There's low amps. So low amps means slow motor. True. That's true. That's a true statement. Or you can look at it and say low volts. And guess what? That's true also. In the first case, the amp flow through here is restricted by this extra resistance. This extra resistance causes the amp flow to go from this to this, and the amp flow is reduced. So we have less amperage, but at the same time, the rheostat is causing a voltage drop, which then causes a shortage of voltage, which causes the motor to turn slowly. So yeah, it works on the same principle. Okay, but what about potentiometer? Well, it's actually the same thing, because what I do is I take the potentiometer and I put my voltage supply here, and let's just say it's 8 volts, because that's what a lot of sensors are sometimes. All right, and we got a potentiometer that's 5K. Okay, so it's going to be 5K ohms. And I happen to have my calculator here, I think. Yep, there it is. Haven't done this math in a long time, so volts over ohms equals amps. So let's see what we got. So we got 8 volts divided by 5,000 ohms. Now 5 goes into 80, 5 goes into 40, 8 times. It's going to be like 1.6 something, I think. Yeah, 0.0016. So it's 1.6 milliamps. So we got very, very low amperage. 1.6 milliamps, which is the same thing as 0.0016 amps. Got it? Okay. So 8 volts divided by 5,000 ohms equals 0.0016 amps. Now this right here should be what you need to see and to know in order to understand why we use potentiometers for ECMs. Because instead of changing 6 amps or changing 3 amps, we're changing 16 thousandths of an amp. That's not much. So the ECM doesn't really see that. So in the systems that I work on, 12 volts and 24, usually what I'm going to see is a 5K ohm potentiometer. So even in a 24 volt system, this is only going to be 32 or 3.2 milliamps or 32 thousandths. I'm 32 ten thousandths. All right, so that's 16 ten thousandths, 1 boy 6 thousandths. Sorry. So at any rate, if we do this, then this is much simpler, because what happens now is my 8 volts here just shows up here. So I got 8 volts here, and voltage coming out should be at 0, so I've got 0 volts here. So what happens is that the 8 volts here, starts here and goes boom, down to 0. All right, so it's going to lose voltage as it goes across, because that's what it does. So it's going to start here at 8 volts. It's going to end up at 0 volts. That's what it does. That's the purpose of a potentiometer, which means that anywhere along this line that we place the wiper, okay, and the wiper right here, that wiper, which is terminal 2, it's measuring that voltage drop. So at this point, the voltage is 4. This would be 6. This would be 2. And anywhere along that line, as the voltage drops, if we move the wiper, then what we're seeing is whatever voltage is there. And we don't care about the amperage, because the whole purpose of the device is to measure voltage. Okay? So rheostat controls flow. Potentiometer measures voltage. Now, if I wanted to do it, I could easily show you the current flow here by saying, well, this is half of 5,000, which is 2,500, and that's half of 5,000, which is 2,500. Well, there's a 4 volt drop there and a 4 volt drop there. Okay, so I could go through and calculate and say, well, I've got a 4 volt drop and 2,400. Let me do it. What the heck? So I got a 4 volts over ohms equals amps. 2,500, sorry, 2,500. Okay, well, it's pretty much the same number, okay, because it doesn't change. So 4 volts divided by 2,500, 0.0016. So the current flow here, the current flow here is the same. All right, so we don't care about the current flow because the word current is not in the name. And here it's in the name. Current's in the name here, not here. So if you want to study this stuff, what you want to do is you want to understand the language, you want to understand the math, and even though they're working on the exact same principle, the name of the device tells us what it does. Okay, so that said, let's get into the hands-on part and show you how this card works.